Now we'll see the next physical property of amino acids is amino acids as a ampholytes. Before that, first we'll see the structure of amino acids. In amino acid, there are the COH group as well as NH2 group. The COH group is acidic group and hence the proton from the COH group is donated to the basic NH2 group, and when proton from COH group is removed, it gets converted into COO minus, while this proton is accepted by NH2 and it becomes NH3 plus. Thus, there is an intramolecular acid-base reaction to form a salt-like structure. This consists of two oppositely charged ions and hence it is called as Zwitter ion. Zwitter means hybrid. Zwitter ion or dipolar ion is a hybrid molecule containing positive charge as well as negative charge. Mostly amino acids, they exist in the Zwitter ion form. Now, see this reaction of a Zwitter ion or a dipolar ion. Properties of amino acids are best explained by considering the Zwitter ion form rather than the uncharged form. This is the Zwitter ion form of amino acid. As here, it contained both the charges, positive charge as well as negative charge. So it is neutral in nature. When amino acids are in Zwitter ion form, they are neutral. But when amino acids are placed in electric field, it is found to migrate towards either cathode or anode, and it depends upon the pH of the medium. At very high pH, means in basic solution, Zwitter ion, it donates its proton to the basic solution and it gets converted into NH2, while COO minus remain as it is. So now it becomes negatively charged. Zwitter ion, initially it is neutral, but when it is placed in the basic solution, like at high pH, it donates its proton from NH3 and it gets converted to NH2, while and the total charge on this is negative. So now it is anion and it migrates towards anode. So at high pH, Zwitter ion get converted into anion and it migrates towards anode, while at low pH, that means in acidic solution, it accepts the proton, Zwitter ion, it accepts the proton from acids and it gets converted into COOH, while positive charge is present as it is on NH3, so it is in the form of cation and hence it migrates toward the cathode. So Zwitter ion as neutral, it remains at one place, but when it is present in a solution of high pH, it migrated towards anode, while at low pH, it migrated towards cathode. However, at some pH value of the medium, the amino acid does not move either towards cathode or anode, and this pH is known as isoelectric pH. Every amino acids, they have their peculiar or characteristic pH value or PI value. Now we'll discuss about isoelectric pH or PI value of amino acids. Just now we saw that amino acid mostly exists in the Zwitter ion form, where it has both the charges, positive charge as well as a negative charge. And the pH at which amino acid exists as a Zwitter ion, that pH is called as isoelectric pH. While at higher pH, amino acids exist in the anionic form and they migrate towards anode, while at low pH, amino acid exist as cation and they move towards cathode. So isoelectric pH is defined as the pH at which molecule exists as a Zwitter ion or dipolar ion and carries no net charge. Thus molecule is electrically neutral. The pi value or isoelectric pH value can be calculated by taking the average of pK values corresponding to ionizable group. All amino acids, they have a pKa1 value and pK2 value. If the average of these two values are taken, for example, for leucine, the pi is calculated as pKa1 plus pK2 upon 2. Average of 2 is taken. pK1 is 2.4, pK2 is 9.6, so average is 6.0. That means at pH 6.0, isoleucine, it is in Zwitter ion form, while if pH is below 6, it is in the cation form, and if pH is above 6, then it is in anionic form. Now, the existence of a different ionic form of amino acids can be very well explained by using the titration curve. Here, the titration curve of leucine is represented. Please see this titration curve carefully. Here, leucine is titrated with NaOH, and as the titration proceeds, it changes from cation to neutral to anion. So, if you see at low pH value, this side pH values are there. At low pH, leucine exists in fully protonated form. It has positive charge and it is in the cation form. While if the titration proceed further, when NaOH is added, then as the titration proceed with NaOH, leucine loses its proton and it loses its proton from here. Now it is existing as a Zwitter ion. It is in the neutral form and that pH is called as isoelectric pH. It is 6 for leucine. Further titration, it results in the formation of anion form of leucine. At higher pH, it is in the anion form. So, at isoelectric pH, leucine is neutral. At low pH, it is cation, and at high pH, it is in anion form.